Disclaimer. Conceptual draft and exploratory idea for discussion, not established physics.
Space emerges from individual phase relations between subsystems. 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 Individual subsystems are the fundamental entities of individual phase relation. Realism. Each subsystem is defined by its relational phases with other subsystems, which determine its potential interactions and the emergence of events. The treatment of individual subsystems is a main difference between individual phase relation realism and algebraic quantum field theory. Unlike individual phase relation realism, algebraic quantum field theory never commits to individuality or ontic separability at the pre-measurement level, and already assumes space-time, even though each relational phase is ontically single instance and unpredictable. The collective behavior over many subsystems reproduces standard quantum statistic. Probabilities emerge from the stochastic dynamics and alignment thresholds, giving rise to familiar born rule outcomes without assuming any underlying randomness in space itself. Phase relations are between individual, potentially localizable subsystems, algebraic slices of the quantum state, which resolve particle indistinguishability and allow space-time to emerge. Individual subsystems form a vast, effectively endless continuum. There is no fixed upper limit on their number. Gravity emerges because mass, energy changes, which individual phase relations between ontic subsystems remain stable. The resulting bias in phase relational coherence patterns is what observers reconstruct as curved geometry. This provides a natural UV cutoff fits within the algebraic quantum field theory notion of subsystem decompositions and identifies the microscopic degrees of freedom implicit in Jacobson's thermodynamic derivation of Einstein's equation. God plays phases, not dice. 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 Space emerges from individual phase relations between subsystems. Space emerges from individual phase relations between subsystems. individual phase relation, encode locality without presupposing space. In individual phase relation realism, locality is not a geometric input, but the structure of individual phase relations between ontic subsystems. When an individual phase relation decoheres and yields a definite outcome, a localized event is realized. Space-time locality is therefore emergent from which subsystem relations remain stable long enough to define consisting causal order. No geometric background is assumed. God plays phases, not dice. 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 Mass energy modifies the stability of individual phase relations. In general relativity, mass energy modifies space-time geometry. In individual phase relation realism, mass energy modifies the lifetimes and stabilities of the individual phase relations that constitute the emergent geometry, mass concentration, accelerated decoherence of certain phase relational configurations, deformation of the relational network, emergent curvature. This is the analog of the Einstein equation at the pre-geometric level. God plays phases, not dice. 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 Curvature corresponds to systematic bias in which relations decohere. High mass energy density shifts which individual phase relations can remain stable. This induces anisotropic and non-uniform patterns in relational propagation, stability, phase coherence decay, and the causal ordering reconstructed from stable relation chains. These bias patterns are what a relativistic observer reconstructs as curved space-time with modified light cones. God plays phases, not dice. 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 Jacobson showed that Einstein's equation can be derived from assuming local equilibrium, thermodynamics of unknown microscopic degrees of freedom, and area, entropy proportionality on local Rindler horizons. In individual phase relation realism, the microscopic degrees of freedom are not bits, strings, or space-time atoms, but individual phase relations in the relational manifold of subsystems. These relations carry entropy, energy flow, and an effective notion of heat flux. Thus Jacobson's thermodynamic derivation fits naturally. The entropy density is a density of relational phase stability. God plays phases, not dice. 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 Unlike quantum field theory on fixed space-time, individual phase relation realism has no infinite localization, no arbitrarily sharp subsystems. Relational phases cannot oscillate arbitrarily fast while remaining stable. When mass energy density becomes too high, individual phase relations cannot maintain coherence and collapse rapidly. This prevents arbitrarily small localization or arbitrarily high-frequency modes. This yields a natural UV cutoff without modifying the field equations or breaking Lorentz invariance. This is one of the strongest conceptual motivations for the theory. God plays phases, not dice. 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 individual phase relation realism. Curvature is the large-scale pattern emerging from which phase relational structures tend to remain coherent, which ones decohere more rapidly, and how these decoherence propensities depend on energy density. Thus gravity is the global geometry encoded by the microscopic coherence, decoherence dynamics of individual phase relations between subsystems. God place phases, not dice. 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 A subsystem is not a particle and not a global mode. It is a potentially localizable, algebraic slice of the total quantum state. This aligns with algebraic quantum field theory, where the fundamental objects are local von Neumann algebras. Each algebra encodes a portion of the universe. Subsystems are defined by tensor factorization or modular decomposition, not by particle labels or global mode indices. Subsystems are flexible, localizable, emergent objects, not fixed momentumals. God place phases, not dice. 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 In algebraic quantum field theory, a subsystem is a subalgebra of observables, not a thing. These subalgebras describe possible measurements, not ontic entities. Algebraic quantum field theory never commits to individuality or ontic separability at the pre-measurement level. Algebraic quantum field theory already assumes space-time. This is why individual phase relation realism introduces something fundamentally new. Individual phase relation realism says subsystems are ontic individual entities, so not particles defined by algebraic separability, not by space-time locality. These subsystems have persistent identity, carry their own probability densities, have individual phase relations with each other, and collectively generate space-time as an emergent pattern. God plays phases, not dice. 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 Individual phase relation realism uses the mathematical idea that the total quantum state can be algebraically decomposed into many quasi-local subsystems. This idea is neutral with respect to geometry. Individual phase relation realism, and that's the crucial ontological layer algebraic quantum field theory does not have. Each subsystem is an individual unit that can enter specific phase relations with other subsystems. Algebraic quantum field theory deals only with statistical subsystems. Individual phase relation realism introduces ontic individual subsystems, a fundamentally different concept. This distinction is necessary for individual phase relation realism to work. God plays phases, not dice. 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 As a working hypothesis, individual phase relation realism might treat a subsystem like a subalgebra B, or a type 1 interpolating factor, such that a state-preserving conditional expectation exists. Operational lexibility, mutual information with the complement is small or localized approximate autonomy, and modular dynamics are stable. God plays phases, not dice. 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 The individual relational phases between subsystems requires new mathematics. One idea for two subsystems, B1, B2 with global state omega. Consider relative modular operators. Delta of omega 1 given omega 2 built from restriction states. The spectrum phase of appropriate matrix elements in these operators yield relative phase data. We propose that one can use modular conjugations to extract a U1 valued phase. Another idea, consider adiabatic or parametric families of local operations for each subsystem. The holonomy of transporting states around a loop in parameter space gives a geometric phase. For single instance ontology, interpret the holonomy as intrinsic relational phase, as a conceptual bridge from ensemble Berry to single instance modular Berry. God plays phases, not dice. 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 Not dice. With subsystems and phases defined, the dynamics can be formalized stages. Deterministic drift. Use modular flows and proper time proxies to define deterministic phase drift between pairs. This anchors gravitational influence on ontic noise at stochastic terms, either as Wiener processes on the phase circle or as jump processes on the algebraic state alignment functional. Define an alignment measure for a source subsystem S toward a target subsystem T built from weighted phase coherences over the relevant phase network of S stochastic hitting time. Collapse occurs when that alignment crosses a threshold, mathematically a hitting time for a stochastic differential equation. Post-collapse update destructs decoherence of inconsistent relations, i.e. randomize or set to undefined. The phase is incompatible with the event consistent constraints. Ensure that post-collapse algebraic updates preserve positivity of the global state and are consistent with conditional expectations. We will need stochastic differential equations on manifold circle-valued stopping time theory, Markov processes on state spaces, and Lindblad approximations for effective decoherence updates. God plays phases, not dice. 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 The mathematical objective is to turn individuality into a state-dependent algebraic selection rule that is operationally meaningful, conditional expectation, low mutual info, dilemma, the stable modulator criteria, and compatible with positive evolution maps after collapse that is challenging, but all of the requisite mathematical tools exist in operator algebras, quantum information theory, and stochastic analysis. It's a matter of assembling them in the right way and testing on toy models. God plays phases, not dice. 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 Defining single instance phases coherently in infinite relate axiomatic U1 field proposals to modular constructions, continuum limit and UV behavior need careful regularization. Split property helps covariance selecting. Subalgebras must be done covariantly. Modular based selection is promising but subtle. Your selection criteria may allow many choices. Physics must single out at least approximately the ones relevant to observers. This is a conceptual and mathematical constraint. Post collapse update rules ensure they define completely positive maps on the algebra. God plays phases, not dice. 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 Because individual phase relation realism treats subsystems as algebraic relationally defined entities rather than spatial parts. The framework must be compatible with relativistic locality from the outset. The natural mathematical setting is therefore algebraic quantum field theory, where subsystems correspond to factorization choices of the global algebra of observables. Importantly, algebraic quantum field theory guarantees that no single observer has a unique or privileged factorization. Even in flat space-time, different choices of foliation, different choices of wedge regions, or different tensor product factorizations of type re von Neumann algebras all produce an equivalent but physically admissible subsystem decompositions. This is well known as the non-unique admissible tensor factorizations in relativistic quantum field theory. In the context of individual phase relation realism, this non-uniqueness is not a bug but a structural feature. A single observer can describe the same physical situation using multiple compatible subsystem decompositions, but the individual phase relations, the ontic relational structure, remain invariant under such changes. They transform covariantly with the algebraic embedding and do not depend on any chosen foliation or spatial slicing. Thus, individual subsystems and individual phase relation realism are not observer-dependent spatial components. They are elements of the relational manifold of compatible algebraic subalgebras. The observer may choose different factorizations of the global algebra, but the underlying network of individual phase relations, the object from which space-time emerges, transforms covariantly under Lorentz transformations, boosts or changes of foliation. This is how individual phase relation realism satisfies relativistic covariance while still retaining an ontic single instance structure beneath the statistical layer of standard quantum field theory. God plays phases, not dice. 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 Algebraic subsystems do not require spatial coordinates. They only require factorizations or subalgebras of the operator algebra, which exist even in theories without space-time. God plays phases, not dice. God plays phases. God plays phases, not dice. Subsystems and individual phase relation realism are not spatial slice. They are algebraic decompositions of the total quantum state, which can be defined purely relationally without assuming space. Space then emerges from the pattern of individual phase relations between these subsystems, therefore no circularity. God plays phases, not dice. God plays phases, not dice. God plays phases,